today going to work on section views, so I'm going to do a little explanation on what section views are. Helps if my little thing's on. Okay, if I'm looking at a section view, basically we have a solid object. Everything that we've been drawing typically is a solid object that needs a top, front, right side view to explain how to build it. When we have solid objects, if there's something in the center of that object that we don't know what it looks like, we'll cut a line, a cutting plane line, which is a phantom line usually, with arrows on it so we can see what's inside, okay? So that means if I just had this solid object, I wouldn't know what this interior piece looks like. So what I do is I cut it in half, okay? And then see these lines here that are in the reddish orange? Those are section lines, or actually hatching lines in CAD. But they're called section lines in engineering drawing. So if somebody says, give me a section view, and here's the other thing. Notice what they touch, what that section area touches. It only touches the solid object, okay? The solid piece that it can cut through. Notice when it goes through the holes, there's no hatching in those areas, okay? Because those holes, it's empty space where that cutting plane goes. So imagine you're taking an apple and you're cutting it in half, okay? You break it apart in half and you can see the core of the apple. Well, you wouldn't have been able to see the inside core of the apple unless you cut it in half, so you have no clue what that interior looks like. So the whole purpose of this section is to see what the interior looks like. For example, if I had this as a solid object, I wouldn't really know how the interior depth of this is a spot face, this is a countersink type of recessed area that maybe a screw or a screw head would go into, okay? So the other thing that I want to show you just in mechanical is if I cut this in half, then I can see all the different types of how this plane looks. And I believe we have one of these over in the other room. So when it cuts through, this is called a spot face. And I'm just giving you this heads up for when you get into mechanical drafting, you'll understand a little bit of the terminology. So a spot face means you're going to cut a hole pretty much through it, all the way through the object. And see, it has a little flat area here. That's where maybe a washer or something, or the screw head is really flat and it sinks flush with the object. Drilling a hole to a depth that has a tapered end. So on your drawings, you have to tell everybody how deep you want the object to be cut through. Then you've got a drilled hole that goes all the way through, and then you've got a counter bore. Now the counter bore is actually a little deeper in the head of it than the spot face. Okay? Now here's the thing, does this circle and that circle look any different? How would I know the difference if I was looking from the top view? I wouldn't until I cut it in half and I could see a section view. Okay? And then the last one is a countersink. The countersink actually has tapered. We've all been to Home Depot and we've seen the screws that have the tapered heads, right? Those are the countersink holes. All right? So we also have section views in architectural. For the guys and ladies that are going to the architectural drawings, we have section views like an elevation view is a section view. We know what the inside of the house looks like. This is a foundation, so I need to know what the foundation looks like. Okay? So I can see how it turns at an angle. And here's the other thing. This hatching now becomes showing you that it's concrete or it's some type of material. Okay? This section, and I'm going to go back one, these hatchings represent something specific, whether it is steel, brass, cast iron, concrete, earth, sand, whatever. We use hatching to describe something. So today when we're going over our CAD, we're going to show you the different types of hatching. So in this one, this is earth hatching and this is concrete hatching. Okay? But we still show you what it means. So this is a section view through the side of the building. Again, hatching. So the hatching tells us there's an insulation batting. You know, when you get into a company, they'll actually tell you already what that hatching needs to be, what it needs to be look like. You'll see what it looks like in examples of their drawing already. Okay? This is the understanding what a hatching is. There's different types of section views that you have. You have a full section view. That means I cut the object in half. If I'm looking down at this, I would never know that this is what the object looks like on the interior. Now, you could do a side view of it, but then it wouldn't give you as much information. These would all be dashed lines, right? So when you've got a section view also, when you cut something in half, then every line that it touches has to be a solid line. It's not a hidden line anymore. If this was a true side view, these lines here would be hidden lines, right? You also have your center line. Again, seeing what was being hashed and what is not. Here's the other important thing. When you're looking at the view, when you're looking at the section view, the arrow is telling the direction you're looking at the object. Cut it in half and turn it that direction, okay? You also have half sections. That means we'll take our apple example and we cut it into a quarter, okay? So half sections will allow you to see a piece of it. So this is what the half of it, if I was looking at here and this was let's say this is top view and this is front view. The front of this object, if I was just doing the front, these would be center lines, but you wouldn't see the hidden lines in there. Technically you wouldn't. I don't know why the hidden lines aren't showing up. Should be hidden lines going down here. But when I cut this in quarter, and again, notice the direction of the arrow. When I cut this in not quarter, when I cut this in a half, then I now hatch the solid piece that it touches. Does that make sense? But I don't see it on this side. And this dashed line shows us the center line, and it also tells us that this is a phantom line, that I'm cutting it in a cutting plane way. Okay? Here is a broken out piece, like, again, the apple somebody took a bite out of the apple. If I only wanted to show this key out area, the whole thing I don't need to show. Now they've got their hidden lines in here. So the broke out section, I show all the hidden information. But in this little bite area, or the broke out section, I can show now the important things. That's what section views are for. They are to show the important things of the drawing. Now, this line here, where it's the cutout, that's just random generic. There's no specific rhyme and reason. It's just enough of an area to show this is the section I'm looking at. Okay? You also have revolved sections. Revolved sections means, let's say this is some type of a tool, and the tool is cylindrical and then a bigger cylinder, and it's a solid tool. So maybe I rotate about the center point of the object or some part in the object to show you that it's a circular tool. Why do I need another drawing over here to show you that it's circle on a circle? I could revolve it and go, that's my section. Does that kind of sort of make sense? Okay. Removed section. We do a lot of removed section in civil engineering, specifically to tell you what the cross-section of somebody's property looks like. So maybe it's a steep hill in one area and a flat area in the other. So to demonstrate that, we'll do cross-sections multiple places. So in this one, this says I need to look at it. Looking down on top of this, I can't tell if it's square, rectangular, circular, or some type of polygon, right? Until I cut a section view. They look exactly the same on top, right? So until I look at the section view, then I can tell you what it actually looks like without having to draw side views. Does that make sense? Offset sections. Let's say you don't feel like making a lot of section lines. You're going to make a zigzag line of some sort. Again, telling you where the arrowheads go to draw what you're looking at. So when you cut through here, then you can say this is a spot face, this is a countersink, and this is a spot face. Now here's the thing, is notice this line here is represented by one line. It just gets shoved together, okay? And you're not actually measuring and then going a distance and then measuring. It's not following the path. It is saying, pretend this got slid back to that line, okay? But it allows you to save space on the drawing. When we're hatching, we'll have an ANSI, the American standards of what hatching means. Now, AutoCAD already gives you a plethora of different types of hatching styles. There's the ANSI and the ISO, and then you can even make up your own. We won't in this class, but you can make up your own hatching styles. Now, here's the other thing. Hatch is usually, like this type, is usually done at a 45-degree angle. Now, that's what they tell you to draw by hand, but when we get into AutoCAD, we can rotate this hatching to any degree we want. We can make it go vertically, horizontally, 35, 60, whatever angle you want. Okay? Here's the other thing. Depending on the scale of the drawing, your hatching changes also. Okay? Now, so we have the top, the front, and the right side view. As soon as you see a hatching, that tells you that there is some type of section being cut out. So you're visualizing a half or a full section view of this object. So notice again, the arrows are pointing this way, so when I rotate this, it's like that. Okay? So that's one of the bigger things that has a lot of people, which direction do the arrows go? All right? That is it for the hatching. So I'm going to pause here. I'm going to pause here, and then I'm going to show you some stuff in AutoCAD.